Geometry, Chapter 4, Section 1, Congruent Figures. Our objective in this section is to recognize congruent figures and their corresponding parts. All right, congruent figures have the same size and shape. When two figures are congruent, you can slide, flip, or turn one so that it fits exactly on the other one, as shown below. In this lesson, you'll learn how to determine if a geometric figure is congruent. So you notice on this one, all you have to do is turn it. This one right here, you just have to flip it around the axis. This one you slide. And we're going to learn some fancy words later for the sliding and the flipping and the turning of objects. The key concept, all right, congruent figures. Congruent polygons have congruent corresponding parts. They're matching sides and angles. When you name congruent polygons, you must list corresponding vertices in the same order. So for example, A is the same spot as E, so we need to have the A and the E together, and then B is to F, so it goes B, F, and then C is to G, so C, G, and D is to H, D, H. So we can say segment AB, okay, is congruent to segment EF. We can say segment BC is congruent to FG. And CD is congruent to GH. And finally, DA is congruent to HE. And we can also label the angles as the same. Angle A is to E, B is to F, C is to G, D is to H. And I'll show you here in a little bit an easier way. Maybe we can set that up so you can see it. All right, so problem 1 says this. If HIJK is congruent to LMNO, what are the corresponding congruent parts? Well, here's an easy way to do it. Since we know HIJK is congruent to right below LMNO. So now what you'll notice is I've got the corresponding parts linked together. So HI should be congruent to LM, IJ should be congruent to MN, JK should be congruent to NO, and KH should be congruent to OL. See how we did that? It's just an easy way to make sure we see it. And the angles correspond as well. H is to L, I is to M, J is to N, and K is to O. Okay, does that make sense? Okay, now let's try this one. If the triangles are congruent, so I have triangle WYS is congruent to WMKV. What are the congruent corresponding parts? Well, segment WY's got to be congruent to segment MK. Segment YS has got to be congruent to KV. And don't forget segment SW has got to be congruent to VM. Okay, now don't forget our angles. Angle W is congruent to angle M. Angle Y is congruent to angle K. And angle S is congruent to angle V. Okay, pretty easy stuff. So using congruent parts, multiple choice, the wings of an SR-71 Blackbird aircraft suggest congruent triangles. What is the measure of angle D? Well, if they're congruent triangles, there's angle D. It would probably match up with angle A. So C and F are both 75. So the rule about a triangle, the sum of all the interior angles has to be 180. So it would be 75 plus 30 plus the measure of angle D equals 180. So that'd be 105 plus the measure of angle D equals 180. So subtract 105 to each side. The measure of angle D equals 75. So the measure of angle D equals 75. So the correct answer is B. All right. Suppose that triangle WYS is congruent to triangle MKV. So let's just draw us a triangle. WYS is congruent to MKV. The measure of angle W is 62, that's given, and the measure of angle Y is 36. What is the measure of angle V? So S is congruent to V, right? So what do we know about a triangle? The measure of angle S plus 62, so I'm taking that angle plus 35, all that's going to equal 180. So the measure of angle S plus, we're going to sum like terms, 97 equals 180. Subtract 97 to each side. The measure of angle S is going to be equal to 83. So if the measure of angle S is 83, we know the measure of angle S has got to be equal to the measure of angle V. So the measure of angle V must be 83. Okay. Next example. Finding congruent triangles. All right. Are the triangles congruent? Justify your answer. Okay, so I have, let's look. Angle B is congruent to D. All right. Angle A is congruent to E. These angles are the same because they're vertical angles, so all the angles equal up. Now let's check our sides out. Angle side 6 equals side 6. This tells us congruent parts, and 4 is equal to 4. All right. Another way we could do it. So yeah, they're gonna be congruent triangles. Another way to do it is rewrite your triangles with matching sides. So we know angle A and E are the same. We know angle B and D are the same. We know BA is congruent to DE, so we have that marked right here. We know BC is 4. We know DC is 4. And we know angle C is the same because it's vertical angles. And then we know AC is 6. And we know EC is 6 as well. So we're able to prove all angles are congruent. And all sides are congruent. So therefore it must be a congruent triangle. Okay, next example. Is triangle ABD congruent to triangle CBD? So let's go ahead and draw our triangles. So we know DA and CD are the same length. We know that, okay? That is all we know right now. Can we know anything else? No. We don't know anything about angle A. We don't know anything about angle C. We really don't know if this is a right angle. So that's all the information we have. So right now, we don't have enough information, not enough info. Again, we just don't have enough information. If we knew this was a right angle, that we could definitely solve that it was congruent. So again, just not enough information. All right, theorem 4.1, third angle theorem. Okay, here it goes. If two angles of one triangle are congruent to two angles of another triangle, then the third angles are congruent. So here's the example. If angle A is congruent to angle D, and angle B is congruent to angle E, therefore we can conclude angle C is congruent to angle F. Let's prove this really quick. Okay, We know the measure of the three angles of a triangle equal 180. That's the definition of a triangle. All right, so we can say measure of angle 1, A, B, and C equals 180, and we say D, E, and F equals 180. So we can say the measure of the angles are equal to each other. We know if the measures of angle A plus B plus C equal, and we know the measure of angle D is congruent with A, we can replace by substitution. And if we know a measure of angle E is congruent to angle B, we can substitute. So we have the measure of angle A plus the measure of angle B plus the measure of angle C equals the measure of angle A plus the measure of angle B plus F. So we subtract A and B from each side, so we get the measure of angle C is equal to the measure of angle F. Okay, and here's an example again, just exactly what we just worked through. We have what we given, the definition of congruent triangles or congruent angles. We know the measure of the angles equal 180. That's the triangle angle sum theorem. Then we use substitution, and then we get the measure of angle C is equal to the measure of angle F. So we prove the angle measures or angle C and F are congruent. Next example. Okay, let's look. Prove triangle congruency. Given the measures of angle LM, segment LM is congruent to LO, so we know that side is congruent with that side. We know MN is congruent with ON, and we know the measure of angle O is congruent to the measure of angle M, and we know the measure of angle MLN is congruent to OLN. Can we prove triangle congruency? You know 4 pairs of congruent parts. What else do you need to know? You need a third pair of congruent sides. Okay, what do we know about the measure of angle LN? Or sorry, the length of segment LN. It's congruent to itself, right? So statement 1, we list the congruent sides. Then by the reflexive property, LN is congruent to LN. So we've proven all 3 sides are congruent. We've proven the 2 angles are congruent because that was given, so we can prove the third angle is congruent as well. So we can say the measure of angle MNL is congruent to the measure of angle ONL by the third angle theorem. So we've proved 3 sides congruent, we've proved 3 angles congruent. Alright, so let's look at the next example. Given the measure of angle A is congruent to the measure of angle D, and we know all 3 sides are congruent. AE is congruent. So let's write all that stuff. So here's our givens. We know all 3 sides are congruent. We know AE is congruent to DC. EB is congruent to CB. We know BA is congruent to BD. So there's our 3 sides of congruency. So we have angle A is congruent to angle D. Alright, that's all given. So we need to prove the 2 other angles. So how can we prove angle ABE congruent to DBC? Well, they're vertical angles, right? So we can prove they're congruent. So we can say angle ABE is congruent to angle DBC because they're vertical angles. Okay? So now I can prove angle E is congruent to angle C. How? Third angle theorem. So I have 3 sides of congruency and I have 3 angles of congruency, so I've proved congruent. Okay, so here's some questions for you. Take your time, pause, and let's work through them. Given QXR is congruent to NYC, QX must be congruent to NY. Angle Y must be congruent to angle X. Alright. So given band is congruent to luck, angle U must be congruent to angle A. DB must be congruent to